All right, number 11. Suppose the probability that a passenger will miss a flight is 0.0994. Airlines do not like flights with empty seats, but they also do not desire to have overbooked flights because passengers must be bumped from the flight. So we're going to suppose that an airline has a seating capacity of 56 passengers. If 58 tickets are sold, what's the probability that 57 or 58 show up? Okay, so they tell us the probability that they will miss the flight, so they will not show up. I'm going to call that the 1 minus p. So 1 minus p, the probability that they don't show up, because we want to know the chance that they do show up. So 1 minus p, that's the failure rate. Some books use Q. I would love to use Q, but I don't know if that would confuse people. But 1 minus p, the failure rate is going to be 0.0994. Okay, so if this is 1 minus p, then the probability of p would be what I would get if I were to solve for p by subtracting 1 from this. So the actual probability of success would be 0.9006. So you can just do 1 minus the failure rate and you get the probability of success. So the probability that they show up for a flight is 0.9006. Part A wants to know what is the chance that greater than 56 show up. So I'm going to say probability that X is greater than, let's just say greater than or equal to 57. So I want to know that 57 or more, which that means 57 or 58. Okay, so for this, all we need to do is let N be the number that we sold, which is 58, and our probability of success is P, and we want to know greater than 57. So we're going to use StatCrunch. It's going to compute that for us. StatCrunch. We're going to go to Stat, Calculators, Binomial. We're going to change this to 58. We're going to change this to 0.9006. And we want to know greater than or equal to 57. So this is going to count 57 and 58. So the chance that 57 or 58 show up is going to be 0.0171. 0.0171. Okay, so we're going to say, I'm going to round it to 4 decimal places. Part B, suppose we sell 62 tickets. What's the probability that a passenger would have to be bumped? So if we sell 62 tickets, so same scenario, now we've bumped N up to 62. So B, we now have N equals 62. And so now we're still looking for the probability that somebody being bumped, which means more than 56 show up. So it's the same thing right here, greater than or equal to 57. However, what that means now that we have up to 62, that would be 57 plus 58 plus, and we will go all the way up until we got to 62, the maximum number. So we're going to go from 57 to 62. So if we pull up our StatCrunch, we're going to just change this to 62. So my maximum number of tickets have changed. We still have the same probability, and then we're still computing a passenger having to be bumped. That's going to give us 0.4103. So it's very likely, almost a 40%, 41%. 0.4103. 4103. All right, and then part C. So a plane with a capacity of 250. What's the largest number of tickets that can be sold to keep the probability of a passenger being bumped below 1%? Okay, so part C. Anything, we want to know the probability, we're looking for a probability that X is greater than or equal to 251. So this is going to be more than 250 seats. Okay, we need to find N. What is that number? What is that number of tickets that we sell to keep this below 1%? Because whenever I do this, I want this amount to be less than 0.01. So I'm going to be playing with different values of N. So if I sell, 260, 70, whatever, if more than 250 show up, which is 251 and above, I want that probability to be less than 1%. Okay. So probability of showing up is still the same. We're playing with N, so the best way to do that is just guess and check with technology. So right now I'm going to say greater than or equal to 251, because if more than 250 show up, somebody has to be bumped. And we're going to start out, let's just say 260. We're going to sell 10 more than what we can hold. So if I hold 10 more, 0.0000, so that's less than 1, but I want to know the maximum. So let me change from 260 to say 270. Okay, so when I go to 270, that's too much because there's a 6% and I want this to be less than 1. So let me go halfway, let's say 265. Okay, so 265 is 0.004. This is less than 1. So let me go to 266. I want to know the closest I can get. So 266 is still less, it's 0.008. So let's try 267. Okay, when I hit 267, we got a 1% and some extra decimals. So that's going to be too much. Okay, so 266. So we can sell 16 more than the flight will hold, and we can be less than 1%. So using technology, just guessing and checking, N will be 266 to keep us below the 0.01. So we're going to say 266.